Hi friends, welcome back. This is Jajish Thomas from omnisecure.com. This is the continuation of the video lesson yesterday we created for class C subnetting, 1-bit and 2-bit class C subnetting. I was not able to show you this lab yesterday because Tiny Kernel Linux, which we are using along with GNS3, was not supporting a subnetted IP address on to configure on it interface. I just recreated this lab using VMware to show you how really these subnetted networks work in real environments. So I created a topology similar to this in VMware. We have 4 XP computers, XP01 with an IP address of 192.168.10.10 with a default mask of class C mask of 255.255.255.0, XP02 with a IP address of 192.168.10.11 with a default unsubnetted class C mask of 255.255.255.0, XP03 with an IP address of 192.168.10.130 with a mask of 255.255.255.0, and XP04 with an IP address of 192.168.10.131 with a default class C mask of 255.255.255.0. And all these devices are connected together by using VMware Virtual Switch. We'll go to that VMware machine. Okay, this is XP01. You can see it here, XP01. So you can see the IP address is 192.168.10.1 for XP01. We'll go to XP02. You can see the IP address for XP02 is 192.168.10.11 with the default mask of 255.255.255.0, class C mask of 255.255.255.0. XP03. For XP03, we can see the IP address is 192.168.10.130 with the mask of default class C mask of 255.255.255.0. Go to XP04, the last one. So for this computer XP04, the IP address is 192.168.10.131. Okay, everything is in the default mask, everything is having the default class C mask. So if you remember the picture yesterday we used to explain this. Okay, this is an unsubnetted class C network, and for unsubnetted class C network we can see the first network address is 192.168.10.0, and the first usable IP address is 192.168.10.1, 10.1. Second usable IP address is 192.168.10.2, third usable IP address is 192.168.10.3. it will go up to 254 is the last usable IP address, and 255 is the broadcast address for directed broadcast address for the network 192.168.10.0/24 network. Right. So which IP addresses we can use? We can use from 192.168.10.254 to 1. These two addresses we cannot use it because 0 is the network address for 192.168.10 network, and 255 is the directed broadcast address for 192.168.10 network. So this concept is clear, right? So all the IP addresses ranging from 1 to 254 can be used inside the network, and they belong to the same network. That means we have direct connectivity between all the devices configured with any IP addresses starting from 1 to 254. So we will check it by using going to the VMware environment. Okay, IP for this computer, this is XP01, the IP address is 192.168.10.0, 10.10, sorry. We will ping to other IP addresses, ping 192.168.10.11. Yes, I am getting an ICMP reply, echo reply, and at 10.130 we are getting an echo reply from 192.168.10.130, that is XP03, and 131. Okay, that also we are getting an echo reply from XP04. So there is direct connectivity, network connectivity between all these 4 devices, 4 computers. All right. Now we will consider a subnetted network case. So consider we subnetted this one using a mask of 25 or a mask of 255.255.255.128. So this one, the mask for this network, mask is 255.255.255.0, default class A mask, unsubnetted. This one 255.255.255.128. We are changing the bar, we are using a single bit by specifying 128 decimal number here. So if you use a single bit, we can divide this network into two parts. So this is left side, I am writing it as part 1. Sorry. Part 1, and this is part 2. So if you use a single bit for subnetting, we'll get 2 networks. First one, this is 192.160. So this pen is not working properly. 10.0 with a mask of 255.255.255.128, and we'll get one more network 192.168.10.128 with a mask of 255.255.255.128. So we got 2 networks. So IP rules state like these 2 networks cannot have direct connectivity. That means a device configured with an IP address of this network and a device configured with an IP address of this network cannot have direct connectivity. That is somewhat related with network segmentation. You have to go and learn that concept, broadcast domain, network segmentation, all these concepts. So that is the reason behind this typical behavior of IP, design of IP, not behavior, design of IP. Okay. Now here for first network 192.168.10.0, 0 is the network address, 1 is the first IP address, 192.168.10.1 is the first usable IP address, 192.168.10.2 is the second IP address, usable IP address, 192.168.10.3 is the third usable IP address, and we learned yesterday it will go up to 126 is the last usable IP address, 127 is the directed broadcast address for first network, and 128 is the network address for the next network. Correct? 129 is the first usable IP address, 130 is the second usable IP address, 131 is the third usable IP address. It will go up to 254 is the last usable IP address, and 255 is the directed broadcast IP address for the network 192.168.10.128, second network. So our IP addresses, what are our configured IP addresses? 10.11, 10.1, 10.10, 10.11 and 10.130 and 10.131. That means if you use a mask of 128 here, if a mask of 128 here, if a mask of 128 here, we use a mask of 128 here, what we are getting from this topology is these two IP addresses belong to one network and these two IP addresses belong to another network. These two IP addresses belong to the first network. Which network? 192.168.10 network slash, sorry, this network 192.168.10 network with a mask of 252.252.128, and the other two IP addresses, that is 130 and 131. 130 and 131 belongs to a next network, 192.168.10.128 network. That means you cannot have direct connectivity between these two, but these two 10 and 11 can communicate together, and 130 and 131 can communicate together. We'll change the IP addresses again. Go to XP01. So sorry, I meant the not IP addresses, subnet mask. So here, instead of using a mask of 255.255.255.0, we'll use the mask of 255.255.255.128 for all the devices. XP02. SP03, two 128. That is a single bit mask. Here also 128. So 10 and 11 now belongs to first network, and 130 and 131, the IP address 130 and 131 now belongs to the second network. So we'll check, can we directly communicate between these two? So we'll ping 192.168.10.11. Yes, we are getting from my ICMP reply from 192.168.10.11, because these two IP addresses 10 and 11 and belongs to which network? This network, right? We will try to ping to this IP address 130. Previously, you remember, previously it was pinging destination host unreachable. There is no direct connectivity. You are not getting a reply because now both the network belongs to two different networks. See, now you cannot have direct connectivity. You need a router to connect between these two. So how the topology is? The new topology, the change topology. If you want to work it together to make it all that the networks of, to make a device configured with an IP address of first network, to communicate with a device configured with an IP address of second network, you need a topology something similar to this. You need a router in between to forward the traffic from first network to second network. Okay. So now typically we use the first IP address. Normally we use the first IP address to configure as the IP address of the first interface, the interface which is connected to this LAN, our 192.168.10.0 network. Now you see that our mask is changed into new mask 255.255.258. That means this is one network and this is another network. And this IP address is the default mask. That is the first usable IP address of the second network. So now these devices can communicate to this IP address, obviously, because these all belongs to the same network, and this IP address belongs to the first network, right? 192.168.10.1. 192.168.10.1 belongs to the first network. So these two devices can communicate to this IP address, and these two IP addresses devices can communicate to this IP addresses, because these IP addresses 192.168.10.130, 192.168.10.131, 192.168.10.129, all these IP addresses belong to the same network, and these all three IP addresses belong to the same network. Now the router will be able to forward traffic from one segment, network segment, to another segment. Okay. So this yesterday I tried to show you yesterday, but I don't know, because maybe my configuration error or not sure. TinyKernel was not supporting it, so I just recreated the lab only for your information. Thanks a lot for spending your time to watch these videos. I hope you understood the concepts which I tried to explain. I request you to please forward your comments and feedback to following email addresses: admin@omnisecure.com, author@omnisecure.com. If you believe the time you spend here is worth, please give us a like at our Facebook page. facebook.com/omnisecure. This is Jajish Thomas from omnisecure.com. Thanks a lot for watching.